Hello and welcome back on another episode of Better Backend Software Engineering. So today we're back with live DDD coding for another episode. So last time where we left off was that we had built mostly the root aggregates, the domain object for a simple library IT system. So the requirements were pretty simple. We wanted to be able to search books, and then we wanted to be able to borrow a book and then return it, declare it lost, declare it destroyed. We also wanted to track ongoing borrowings, and if one is past the return date, then we want to ban the user and mark the book as lost. So that was sort of the high-level requirements. And what we had left off is that we had built most of the domain. So we had the book. This is mostly the root aggregate. And so the book has a bunch of searchable fields, a status, of course, which comes shipped with a state machine, a very basic one. And then it adds borrowings. So borrowings is an entity that represents a book being borrowed. Of course, a single book can only be borrowed once at a time, at least in today's domain. We can figure more complicated use cases later. And so we had shipped this book with a bunch of domain function that guarantees that the book itself, the book entity, and the book aggregate as a whole is always correct. Now on top of this, we had author ID. So we basically left it off saying that in order to search a book, we would need to search by author ID rather than a fuzzy search on author. This would make things more complicated. And if we want to do this in the future, we'll just think of better ways to do this. So there's just author ID as of today, but potentially that means we also might need some sort of author repository or something. And then on the other end, we had the user as well. So user was pretty basic, had a status, had a name and an ID. So we also had built a repository. So the repository there again was very simple and just an interface. You can find books by all the different fields that we've mentioned. And you can save book and find a book by ID. So that was it. Now, there's probably actually more interfaces that we want to have right now. We probably want what I will call a user manager. Okay, that's very weird IntelliJ, but whatever. I've never seen this before. So what we want the user manager to do is very simple. We know from our previous requirements that we want to be able to ban a user, and we know as well we want to be able to potentially retrieve a user. So let's get into a bit of action, shall we? So now the next thing we want is essentially we want to ensure that some operations happen atomically. So I'm gonna note this here very informally, but one second, should happen atomically. And so the first one is yes. So when a user borrows a book, the book must be marked as borrowed. And most important, actually, this is rubbish. Copilot. So the book must be marked as borrowed, but what we also want is a task to be scheduled. And that task should be scheduled in order to verify that by the time the book is supposed to be returned, it has indeed been returned. And if not, then it should mark the book as lost, and it should mark the user as banned. And so the second one is that the book must be marked as available. No, that's not that. The second thing is that when, sorry, I tried, but this was just not good. The second thing is when we process this task, we also need atomically to move the book from borrowed to lost and ban the user. So in both these cases, we want to do these things atomically. Why it's so important is because in the future we might develop new use cases. And these use cases might bring in and compose the domain in different ways. But we still want to guarantee this atomic operation still happens atomically. And so for that to be a thing, then the only proper way to do it in DDD is to ensure this from a domain level perspective. So right, let's get to it. Let's try to actually build that. And disclaimer, this is actually not going to work, but this will remain an interesting point for this part, which is how to build these DDD domain services. So the first thing is that we're not going to allow calling borrow from anywhere else than this book package. So this becomes package private. We're gonna do the same with declare lost. Potentially the others as well, but for now it's not needed. And so the first one we're gonna call it borrow book. Well, this is super weird. I don't know why IntelliJ does this to me today. It's working better before. And so what it's going to do is, so you can assume that it's going to have, well, task scheduler. I'll go back to that one. That's an interesting bit. But for now, we're not going to talk about this. And it's also going to have, well, we're going to need probably this. So I actually need to define the other one first, in fact. So we call it declare lost. So we're gonna first create the class declare book lost. So there we go, declare book lost. This also will require some things to work. One of them will be the user manager. I think that's actually all, in fact. So yes, so no, we don't want to do this. In fact, we would like a borrowing thing in that case, and so what we're going to do, no, we want to book as well. And so what we're going to do in that case is something like this. Book.declare lost, borrowing.getID, and then yes, we're gonna ban the user. So on the other end, this one will look like this, and it will, well, yes, of course, I want my user there. It will do this, and borrowing.get due, I think due, there's something, get return due at. Yeah, so we want to borrow the book and then mark the task as schedule. So what's the issue with this actually? Well, there are several. There is one issue in both of these classes actually. So let's get over the most obvious one. This task scheduler here. So the problem with this task scheduler is that, well, you can see it there. This is imported by org Spring Framework. So here there is a very deep assumption on what's our infrastructure layer. Essentially, we are saying that we are scheduling a task specifically with Spring Framework scheduler. I actually don't know how that works at all. I don't know if that's supposed to write something in the database or if this is just in memory. I have no idea, never used that, and I don't want to. So indeed, we do not want to use the task scheduler here because it strongly applies something on the infrastructure. So in general, we will completely avoid this in DDD. Now, one solution would be that this task scheduler is actually an interface and then it's implemented in the infrastructure layer. The problem with this approach is that in general, in DDD, you would even try to avoid directly suggesting that there is a task schedule, because the fact that there is a task schedule is actually in and of itself leaking the infrastructure, because in most cases a task schedule will require to have a database, and the task scheduling system is in and of itself an implementation layer even without like knowing which task scheduler we're talking about. So ideally, we'd like to avoid this completely, meaning that we cannot actually do this. Well, there are ways to do this in the domain. Typically DDD events, domain-driven design events, but they're much more complicated to set up, and we're not going to talk about them in this video. Now, as for the other, the problem we have here is that, so there are two actions happening, right? And the problem is that one of them, ban user, is done through the user manager. Now, we don't actually, well, first off, this is a public method, meaning that this can actually be called in isolation from another domain layer. This might not be a problem, because if you think about it, there might be other reasons to ban a user that are not related to losing a book. So it actually might make sense that this function is anyway public. What's more problematic, however, is that we now have an action done through user manager. So we can assume that, well, we don't know what piece of implementation it is, but we can assume that one has to sort of be persisted in database, and the other one might be an HTTP client call, it might be a Kafka event send, something else. And the problem with this is that immediately, because we're doing both in the same domain service, then it means that we're strongly implying within the domain itself that this has to be done in a transactional way. So we're assuming like somehow all the implementations of these interfaces and the application layer that will use it, all of this will be ending this in a way that guarantees this atomicity and with proper transaction management. So we're basically leaking the responsibility of the application, which usually deals with transactions, into the domain, because there's no way you're going to entangle this in this approach. So yes, you can do it on the paper, but that's a bit of a risky business. You have to be sure on how you want to do this. And usually, again, the solution is with DDD events. DDD events is by far the best way to deal with atomic actions that have to be done from different, possibly different subsystems or different tables, even within the same database, or whatever, really, because it has completely no implication on the transaction isolation setting of the overall application and the components it involves. But as I said, DDD is not for today. DDD events is not for today. This is a bit too complicated for the scope of that video. And what we want to move to instead is the application layer. So this one is problematic. This one is problematic. We're basically not off to a good start. So we cannot really do this. Instead, in that case, we're going to do this in the application layer. And with that said, I'm therefore introducing to you the application layer of our application. So now in our application layer, in theory, you can you can allow some Spring annotations, and more importantly, you will definitely, in some cases, imply some of the infrastructure level things. So what I mean by that is you're not going to imply them directly. You're not going to use the implementations directly. Of course, you're going to use only the interfaces, but you're gonna have to handle the transactionality of this. You're gonna have to compose them in a way that guarantees this atomicity, that allows your system to retry actions safely, that allows your system to be idempotent, to recover from certain failure, etc., etc. So that is like totally the role of the application layer on the other end. And that's why that's really not going to work with what we have there. So let's actually consider this, and we're going to move this instead to the application layer. Why? Yes, we want to refactor them. Those are not exceptions. By the way, I didn't touch the exceptions yet. And we will touch them, I think, at another time. Right, so here now it's not very happy because obviously these functions now are package private and they have no access to it. So I'm re-establishing this access. So now this is our application service, and we have a bunch of problem here. Well, we still have no transaction being created or declared anywhere, and we also do not. We still probably do not want to directly use Spring's task scheduler here. In that case, not necessarily because of we don't want to assume the implementation, whatever. At this level, we can. Because we know that there is a database, etc., on the application layer, that's okay. But the problem we have here is that, I just never used Spring's task scheduler, and I have really no idea why it actually is. My best guess is that this is actually in memory. It seems like this is in memory. But let's actually look at what we have. In terms of implementation, these really look like this is in memory. There doesn't seem to be anything about persistence of this task. Right, so anyway. So what I'm going to do instead is that. We're gonna keep this for now, because we're not running the application yet anyway, and eventually later we're gonna introduce a task scheduling system. That's a bit of a mouthful. And the second thing we are going to do, and that is more important, is to actually deal with transactionality. So in a cutoff scene, I just added this application service abstract class, and so I'm gonna explain you very fast how this works. So basically, you pass it a platform transaction manager. This is actually part of the Spring framework, and then it has like a protected method that allows you to execute things in transaction or execute and return from the transaction. Very simple, and so it just means that we're gonna extend this class. We're gonna remove the required args constructor because this doesn't work very well. We're gonna pass it the platform transaction manager, and please, we're gonna also add this too. And we're gonna do the same here. And we actually, in that case, in this one, we're gonna want also the book repository, and we're gonna want that here as well. So we are going to start from this one. And the first thing I want to do is to extract this to a separate function. So I don't know exactly how we're going to deal with these handlers. So what I'm thinking about is that we're gonna make this for now implement runnable, and later if we have like a base task handler archetypes or something, we're gonna make it, well, extend this base archetype instead. Yeah, and so that's gonna be our run function. And so the run function would yeah, with runnable it doesn't work very well. In fact, 1 second. I'll try to make this work better. Is there we can yeah, we can only pass it to runnable, I believe. So okay, we're gonna do this differently. Then I'm not going to use this task scheduler at all. We're gonna have an interface for now, which I'm going to call task scheduler. And so task scheduler, gonna make it part of a package I will call task. We're gonna put our services into another package right there. So we're gonna have a task scheduler, and we're gonna have something probably called task type. And we're gonna have a task handler, also an archetype for now. And we're also going to have this. That's going to be an interface. So basically our task handler will handle something that extends a task data. A task type will also have task data. Actually, I think I'm doing this wrong if I remember correctly. I never remember doing this. If I remember this right, we have to make this like that. I think it's there then. All right. Okay, I think it's there then. Yes. Okay. Sorry, never remember the syntax of that one. Actually, we're gonna call it D like data. Right. And so task scheduler is going to take into account, yeah, so schedule task type of T extends, sorry, I think in that case it's here, T extends task data. We're gonna have a task type. Sorry, it's not task data of T, it's just T right there. And the delay, no, instead we want to pass an instant schedule at, actually, we're gonna pass a zone datetime. Or we're gonna pass an instant assuming everything is in UTC, I think. For now, we're just going to make it extra simple. So this is all it's gonna have. Very basic. We're even going to have a default one, I think. Sorry, default I think needs to be there. And yeah, what it does is just that. No, it doesn't like that, it seems. Yeah, I think that's better. Right. I'm tempted here to put this just to be extra sure. Yeah, I think this will be good. Right, so we have our task scheduler, and obviously it's not implemented. We have a task type, and it's basically um, 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 I think just going to which, by the way, I did something stupid right there. Should have called it D as well. So we call it the same everywhere, and then that's convenient. Well, I could have just replaced it everywhere, but data type might not. Yes, of course. Right. So this is our constructor. Actually, this will be private, in fact. And what we're gonna do is this. Is that yes? So I don't know. Yes, this is more like what I wanted. Exactly. Declare book lost. And then we're gonna have package data, and in there I'm gonna declare the declare book lost data. Sorry, this is a bit of piping, but what we got here now is that we have task types, and that is pretty convenient because we can assume that we can now schedule a given task type with a given task data, and at a given time, very simple scheduler, right? And on the other end, a task handler will have to implement this function simply, handles, and of course then yes, an actual handling function. And so some piece of the code will probably call it, and because you might imagine that this is actually how to put it, this is actually probably using the database, so there's probably a transaction initiated when the handle method will be called, right? And in that regard, this means that we probably won't need to necessarily open a transaction. We probably shouldn't, because otherwise this could create inconsistency with the task scheduling system. But for now, we're not going to care. We're going to assume that there is no already existing transaction running when this handle function is created. So we got this. One last thing here. This is going to have a book ID, and this is also going to have a borrowing ID, and yes, and we're gonna take all the constructors. So an interesting bit here that I didn't mention is that if the task is gonna be scheduled and then picked up later, the data task probably needs to be serializable, and that's definitely not the case right now. I mean, especially if we're looking at JSON serialization, and that's a very interesting use case. But we'll take this in another video. For now, we just don't care about this. Yeah, this doesn't work, but that's fine. I'm actually going to rename it because now I just realized they shouldn't be called declare book lost at all. They should be called check if book has been returned or something like this. I do not like this name very much, Thor. Well, I'm probably going to come back on this. So why? It's actually it's a bit bigger than just declare book lost. In fact, because we're going to check, has this borrowing been returned? If yes, then that's it. That's the end of the task. We're just gracefully complete it. If not, then we need to mark the book as lost and ban the user. So we have our task right there. And in borrow book, yeah, so we're gonna need the book repository actually. And I'm gonna assume that at this point we just have the user ID actually. And this might be wrong and we might have to change this in the future, but that's not a big deal. This is gonna be easy to modify. So we're also going to add it as a constructor parameter. So here this one becomes very simple. So the task scheduler actually, where is it? Yes, so we're going to remove that actually. Yes, and now it has actually imported the right thing. Or has it? Okay, something's going on, it doesn't like it. Sometimes with IntelliJ you just need to, yes, just need to delete the code and put it back. Right. So task scheduler, schedule indeed, task type, no, that's not at all what we want. Yes, and then we want, yes, this one. And yeah, I'm gonna close this. I don't know what's going on with IntelliJ. It doesn't want to color anything. Okay, something's up. I do not know what, and that's a bit annoying. However, in the meantime, I think I've settled on something a bit better. Verify borrowing completed, or maybe book. Wait, don't annoy me. Verify borrowing completed. Well, actually, I still want to make it was completed because verify. Yeah, do the refactor. I don't care. Yes, that sounds better. Okay. Okay. So we're back to this. So yeah, so we're actually first getting our user. Then, well, actually here, this shouldn't be a book. This should be a book ID. So we're gonna get our book from here. All right, so now we're back and we finally have color. So IntelliJ is functioning again. So we're not using the right function to get the book, obviously. We get an optional. Now we're gonna get to define the first application layer exception here, because this is a great use case for an exception. Something that eventually we're gonna catch and rethrow as a proper 404, for example, for API requests. So great. So with that said, I'm going to create this exception. And yeah, I'm gonna call it book not found exception. Nothing very interesting here. I will talk a bit in the future about some patterns that I like to apply with exceptions, and that will help us to make sure we always catch them properly in the presentation layer, but that will be again for later time. So we have our exception right there, and what I'm gonna do is actually I'm gonna call this book OPT for optional, and if book.isEmpty, throw new book exception and handle. Yes, so indeed, because this is an exception, this one is supposed to be handle. Actually, I wanted to extend a runtime exception. Again, I'll get back to why runtime exception here, not exception. That's for that will be unfortunately for another time. So indeed, if we don't have our book, we're gonna throw an exception. Now our book is, well, we just get the optional right. And so the user, basically, this one doesn't even return optional. I think the assumption I made behind that is that the user ID has already been verified in the presentation layer. But it might actually be a bad assumption as well. I'm just thinking, so you know what, I'm going to do things properly. And so here again, we're gonna do this like that. Yes, and we're gonna create a user not found exception. Also extending runtime exception. Also add value and user ID, right. And there, yes. So user equal user up.get. So now we got everything. No, I don't want you to do this, please. And I don't want you to do this either. So what we got there is that, well, again, we have our borrowing, and then we schedule a task, and that's cool. We don't need actually declare book lost anymore, because supposedly now the task scheduler or the task orchestrator system will be able to find the right task handler, and then we'll be able to assign it the task. So that's the convenient thing with doing things this way. So we're gonna remove it from there. Right there, and are we missing something there? No, it's done properly. That's fine. So yeah, so that's cool, except it's not. We got a big problem there. We're not dealing with transactions at all. So, well, we should open a transaction, of course, and we've done it. We've done it with this application service. So we can use the executing transaction function, and well, that's exactly what we're going to do, right? So I'm gonna do tech. Should we? So yeah, here actually that's interesting. Like I was just like, wait, we're just returning the borrowing from this borrow function. Do we need to Well, let's say we do. Let's say we do. So in that case, we're just going to use the executing transaction and return. Now, one thing that I love to do in application layer is the following. And then we're gonna basically require the consumer to pass in a mapping function that maps a domain object to well, whatever you want. Yeah, I guess I messed up again. Yes, that's what I thought. And so what we're actually doing here is that we're mapper, and then I guess, and then compose. What should apply? Yeah, apply. Yeah, that's what I thought. Yeah. Right. So. So now we have all of this thing that execute inside a transaction, and then we map the result to whatever the presentation layer is asking us as a mapping function. It's pretty convenient. However, so one thing here that we can touch is why opening the transaction here, why not later? Well, in general, pretty simple reason is because we are retrieving the data from the repository at this point, so we need to basically close the transaction once we've completed every other operations with database, especially because we're going to write back on this repository. So if we open the transaction later, then we're going to have problems with our transaction isolation, because we're not getting the book in the same transaction where we're saving that book, which, by the way, reminds me that I've forgotten to do the most important thing here, is to save the book. Now, saving the book will also, in DDD world, save everything that is on this aggregate. And so in that case, because our book contained the new borrowing and all of the other borrowings, then it's going to save it, to persist it to the database. Yeah, so just one last thing on this on this topic is that technically what I could have done is this. Because then at least like getting the user is done outside of the transaction, and that makes the transaction a bit faster, and a faster transaction means a better database performance and overall better service performances and less cost. And we might actually want to keep that. The user is almost certainly there because we've most likely checked it already from some sort of authentication or authorization use case in the application layer. So it's safe to say that we could basically just consider it's there. And as for the rest, we need to do it within the transaction. So there we go. Now we got our Brobook application service. Notice that I didn't put a service stereotype here. We're gonna do the configuration separately, but ultimately in the application layer, or presentation layer for that matter, it is okay to use Spring Boot annotations to declare specific components as beans, as Java beans, Spring beans. However, what I really recommend is to not use auto-wired annotations. Auto-wired is really something you want to reserve for extreme cases where you do not have any other solution or choice. And perhaps for tests, I would say it's pretty okay. But for production code, do not do this. Just, it's not worth it. And it will also make writing tests for classes that have auto-wire dependencies much more complicated, especially unit tests. So With that said, so we get our borrow book function. Now let's go back to the second one, declare book lost, and actually, so first off, we're gonna rename it. It's gonna be called verify borrowing was completed handler. So now it's going to implement task handler of right. We still need the book repository, the user manager, and I think that's gonna be all. I don't know why it created like the two constructors. That's totally unneeded. Which, by the way, reminded me that probably I did this one thing wrong. No, I didn't. So this one is purely a task handler, so we're going to put it in the task handler package. There's no need to put it with the services and deal with these extra responsibilities that we have there. For example, with the mapper function or the sort of things. That doesn't really make sense. So we need the user manager, as said, and the book repository. Yes. Thanks, but feel free to assign this parameter as well there. And so yeah, so we're gonna do this. So return task type equals. Yes, that makes sense, except that's not going to work. Well, okay, yes, that will work if we think value. Yes, value. That will write for me the equals and hash code functions. So then the equal check will actually work conveniently. The next thing we actually I'm going to change that a bit. Sorry. Let's go to task handler. Actually, we're gonna make this. Well, okay, no, that's fine. Let's do it like that. For now, sorry. So, you actually don't want this actually. Sorry. For now, that looks like very extra to me. I think we don't want that. So yeah. So now we need to write the code here on how we're gonna handle this, right? And so what we essentially need to do is that we need to get wait. No, I do not want that. Okay, this is a bit annoying. One second. Get. Okay. Very stupid error here. Indeed, we do not have any getter. So this is Lombok again. For those who don't know, this is very convenient. Could have used records as well. No, this is quite convenient, but I've been quite used to Lombok lately, so I'm just gonna use that. Right. Okay. So. Right. So we cannot get the user actually right now, and I think we're not going to need it. So what we need is the book. So again, I think we're gonna make this. Yeah. Optional of book, exactly. Yes. No, not illegal argument exception. We're gonna also throw our book not found exception. Ideally for task, usually I would resort to different task specific exceptions. We'll see why it can be more convenient. But well, in that case, that's fine. Again, like I think I'll have a full-on session on exception handling for another time. So, so the second thing we want to do now is to is to get the borrowing. So this is a function that actually do not exist at the moment. So we're no, sorry. And we don't want the borrowing, i.e. we want the whole object. We're actually going to call it or throw. I think it's simpler to assume that. No, okay, sorry. I did something stupid. Book. Oh, did I already? Right. So my function is where is it? Where are we? I'm lost again. Seems so. Grad is boring. The idea here is to check is overdue. So if it's overdue, we're gonna ban the user. No. Which, by the way, there's a little issue there, is that as a result, the ban user function should actually also modify the user object. Well, in that case, the user object is not passed, so I guess that's fine. But we potentially have to modify the signature in the future, because it's not clear there's a side effect on the user itself in terms of, well, if you already have, for example, say, if I had a user object here, my user would still be in a non-banned state after calling this ban user thing. So that's not excellent. And anyway, that's the first thing we're gonna do, and then the second thing then is book declare lost, and now we're gonna save it. So there is a little something here, is that, so in theory, if we fail to ban the user, then the task, well, it should probably be retried until it's actually successful, and so until we can actually save the rest in the database. So there cannot be a place where we actually have the book that is marked as lost, but the user hasn't been banned. But that's a bit of a weak implementation, because now we essentially have two different transactions in a single transaction. So there again, I'm coming back to DDD events, but DDD events are still way superior in that sense for that specific use case, because they would have allowed us to do these two operations atomically, but within two separate transactions, and each being a separate task, and each being having a separate task handler. And so this basically gives us the maximum protection against any sort of issues, and it allows our system to stay as consistent as possible anytime. So so this is basically our handler, and now we have our two basic atomic use cases that have been defined. So as we've seen earlier, we've tried to put them in the domain. It doesn't work for the many reasons we've invoked, and many problems we have around consistency, etc. And so we've managed to put them here in an architecture where we have like task handlers and we have like application service. Now there's a lot of things that we haven't done yet in terms of the use cases that this application is supposed to meet. So we'll talk about this next time, I believe. Or we might move a bit to application layer. We'll not completely sure yet of what's going to be the next step. Anyway, so yeah, so there will be more of these videos, of course, and I hope you like the content. I would love to have your feedbacks, questions, or whatever in comments, so feel free to post them. Really, I'm looking forward to them, and I'll be replying. Yeah, make sure to like and subscribe. This will make a big difference. And till next time for the next part of these live coding sessions. Thanks again for watching me, and see you next time.